In this video, we're going to talk about the problem of searching inside of a graph, and we're going to take a look at two primary approaches to searching. Those are known as a breadth-first search and a depth-first search. So to start off, we'll introduce the idea of searching in a graph. So the idea here is, imagine that we have some sort of graph, and I'll just draw out some graph for us to work with, right? Maybe we have something that looks like this. And the goal of a search is to see if we can reach one node from another. So if we can create a path from one node to another. So for example, suppose I wanted to find out if I could create a path from 0 to 4. That would be an example of a searching problem. And in this case, we could see that there is one. We could go from 0 to 1, 1 to 3, 3 to 4, and we have reached our destination from our source. To do this programmatically, there are two main approaches that we would have: a breadth-first search and a depth-first search. We've actually already seen these ideas in trees, but now we're going to be introducing them a bit more generally. So the idea of a breadth-first search is we start at the location that we want to start at. We then search everything adjacent to it, and then we continue on searching everything adjacent to the nodes that were adjacent, and we continue on that until we find what we're looking for. So in this example here, if I wanted to start at 0 and try to get to 4, I would start at 0. Then I would search to 1 and 2. So both of the things that are adjacent to 0. I haven't found what I'm looking for yet. So what I do is I move on to my next node and add its adjacencies to the things that I'm going to search through. So that would be 3. And we've already reached 2, so we don't need to add it again. So we're smart enough to be like, okay, we've already traversed to 2, so we don't need to traverse to it again. So we don't add this edge here into our set. 3 isn't what I'm looking for, so I'm going to add its adjacencies next, which I see is 4 and 5, right? And at this point, I've found what I'm looking for, which is 4. So we could stop here and say, yep, 4 has been found, and we're all good. Do you see how that traversed all of the adjacent nodes every single time? That's the idea of a breadth-first search, right? So it's going to move through all of the adjacent nodes piece by piece. And actually, you saw something pretty similar to this idea in our level order traversal of a tree. So when we looked at the level order traversal, what we had was something like this. We wanted to try to traverse all of the different levels of the tree. And the way that we did that was we started here, and we took a look at the two things that were adjacent. And then from here, we added their adjacencies and printed them, and then their adjacencies and printed them. Do you see how that goes through adjacency to adjacency? That's another example of a breadth-first search. So we saw that inside of our tree as well. Now the second kind is a depth-first search. A depth-first search is going to go through the whole depth of one path before moving to the next one. So let me give you an example of this. Suppose that we had a graph that looked something like this. I'll just draw out one that has like a lot of different edges because it'll make it pretty easy to see. Something like this, right? If I wanted to search for a node starting at A, a depth-first search would go like this. It would go to B and then traverse down to C. So it's going to traverse everything that's adjacent to B first. Then it moves to the next node. It will traverse what's adjacent to D next. So it goes all the way down here, then all the way down here, and then G will be traversed. This is counter to a breadth-first search, which would have traversed B, D, and G, and then C, E, and F. This one actually traverses all the way down to B to G, or from B to C, and then D, E, F, and then G. So you see that it approaches it in a slightly different way. We again saw this exact idea in our tree as well. Some of our traversals would move all the way down to the left-hand side and then come up back up to the middle and search their adjacencies and so on like this, right? So we did have something like a depth-first search as well. So these are two different approaches to the same problem. In both cases, we're trying to determine if there's a path from a starting point to an ending point, and there are two different approaches for us to be able to do this. We'll see that these approaches work very well for different kinds of problems. In some cases, a breadth-first search is going to work really well. In some cases, a depth-first search is going to work really well. To start off, all we're going to do is just implement these algorithms as they are. I'm going to show you how to create a breadth-first search, how to create a depth-first search, and then later on we could take a look at different ways that those are applied and different things that we could do with the breadth-first and depth-first search. So thanks so much for watching this video, and I will see you in the next one.